Great. So thank you for coming back. Today, I'm just going to open up our page. So we're on our main page again, rockefelleruniversity.github.io. We're just going to cover the last part in our first session today of Introduction to R. It's actually a very useful part. It's how we can create custom functions, custom utilities for ourselves to use. In our second session today, I'm just going to skip down to reproducible R. We're going to do a little bit about how we can turn our scripts, our bit of code, into pretty reproducible reports, which we can then share, but at the same time capture everything we've done. Okay, and that's a really lovely thing about R, something we can do later on. So we were in Introduction to R. We were in our session 2, and we'd covered a little bit about, so I'll recap, but we covered a little bit about conditions and loops. So how we can loop through things and then apply if or else to do a little bit of programmatic kind of work. So just remind ourselves here, I'm going to create a vector x, and that is a vector of length 10. So I have 10 indexes there. If I want to access one of them, I can just number the one I want to access. To do a for loop, we saw we can just do for, and then we say what we want to loop through. So we're going to set I in here, X. So we're going to loop through X, and every time it goes through the loop, I will take on the value of the loop's index. So I do Xi, and I just use the message function to tell us what the value of Xi is as we go through the loop. We can see I takes on the value of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. In fact, I don't need to look at X. I can just look at the I value here. We can then add a little bit of conditions to this. So we could say if I equals 2, and then we do another brackets. So now it's only going to come into this loop, and it's only going to evaluate this message should I be 2. Right. Inside this, we're only going to get a message for 2. So the only time that this evaluates to true is the second time through the loop when I takes on the value. We can also add a little bit of else to this, so we can have options. If the top one evaluates to be false, so if I is not equal to 2, we can put something different in the else. Help, not 2. Okay. And then we can also capture multiple conditions if we want to by adding an else, but following it by an if. So in this case, I equals 3. Do this. Oh, sorry. 3. Okay. That was interesting there actually, because I set that to be 2 and we got nothing. And that's because that had already been true here. I mean, so there's never a circumstance where I can be 2 here, but not 2 here. Okay, so very simple, we can do loops and conditions within those loops. Sorry. Give us a little bit of programmatic. So most of the time, what we're going to be doing is looping through sets of files, maybe columns in a file, and applying a function to that. So one last thing we did see last week, which is really useful, is we also saw the functionality of things like lapply, which allows us to loop through a vector, let's say X here. Okay. So we can loop through a vector, apply a function, and in this case, lapply will return it as a list. sapply will return it as a vector. And if we want to operate on matrices, let me build a matrix quickly. We also have this apply function, which allows us to apply a function to the columns or rows of a matrix. So in this case, I'm going to apply the sum to the rows. So this is my matrix. I say 1 if I want to operate across rows, 2 if I want to operate across columns. So in this case, we're going to get two values, 25, which is the sum of the first row, 30, which is the sum of the second row. If I did 2, I would get the sum of all the columns. So we saw a little bit of this last week, and that was in our first session for session 2. So the last thing I wanted to cover for a little bit of R is custom functions. So the way I've designed this course, and really in your own work, you don't actually need to write that many custom functions. And in fact, the whole course could be done without ever writing a custom function. That said, I think I would be doing you a disservice if I didn't teach you a little bit about custom functions in R. And really, custom functions are just throwaway routines that we can program ourselves and then apply to our own. So we've already used functions like sum. And if we look at something like, let's try sum, right? We know sum takes the arguments we want to sum up. Okay, so it takes arguments. We have the name of the function sum. We have brackets. And then we have the arguments we pass to it. We build custom functions very similarly. We just need to use this function statement. So we actually have a function. Okay, so we assign this function to the name, what we want to call our function. So here I'm going to create a function called my first function. I assign to it, and I have function here, and then here I put any arguments, any parameters that I want to pass into my function, which I want to be used by my function. And then I put the code I want to execute within my function. Usually this would do something to this parameter. So I would usually say pass in my argument, times it by 2 or something. And then I want to return whatever happened in the function, whatever result I generate. I need to return that out of the function back to the main R session. Okay, so we've got the name of our function. This is what we're going to assign. This is what our function will be called. And when we want to use it, we will have to do that name, like every other function, parentheses, and then the arguments. We specify any arguments we want to use in our function here, and then the code to evaluate here. Importantly, every function will return something, or try to. And here we have return, and this is the result, numeric, list, whatever, which is returned back out of the function. So I say I'm going to do the square function. We're going to do the sum function. But just to show you it in action, we can do, this will be the name of our function. We're then going to assign that to it. We're going to use the function, right, this function statement to create it. And we're going to have 2 arguments, which I want to pass into this function, num1, comma, num2. And then inside the function, I'm just going to add num1 to num2, assign that to a new variable. And importantly, I'm going to write return sum. Okay, so I'm actually going to return out of the function this value. Okay, so then when I run it, I use the name of the function assigned here. I have my argument names here. So num1, num2. I assign 2 to num1, 2 to num3 to num2. And internally, we don't see this now. It's going to add these 2 together. It's going to return that result. And then my result is going to retrieve or be assigned this sum num. So 2 plus 3 is going to be my result, 5. Okay. So see this in action. To do that, usually I would just down to some script here. I'm going to save this here. Just make, if I run this, I then have that function available to me. Like first function, and then num1. You can see actually it's quite clever. RStudio is already filling in parameters are there. Num2 equals 7. There you go. So very simple, just to create a very basic function. Now, a really important thing, and I think most functions across most programming languages do something quite similar here. Functions only really want to return one object at a time. Okay. So I think naturally when you first start doing this, you'll try something like this, right? You're going to create here, we're going to try and get the sum, and we're going to try and get the multiplication of these two numbers. So it's the same function as before, we're just adding this additional line here, num1 times num2. And then if I try and do the return statement, like you might imagine, return is a function, and I just provide the arguments I want to return, sorry, the objects I want to return separated by a comma. And if I try and run that now, it's going to say multi-argument returns are not permitted. Because actually, if you think about it logically, I am just assigning, this is the function I'm running, and I'm trying to return two objects to one object here, right? So it's just not going to work. What would it do with it? Okay. So when we run a function or when we create a function, we can only actually pass back one object at a time. Okay. That's actually not a big problem because we have objects in R, like vectors, which can hold multiple values, right? So we just need to create something which has the values we want to return up front, and then we pass that object to the return function. So in this case, I'm just going to have the same function again, but I'm going to add, after I've done the multiplication, I'm going to create a vector of results, and I'm just going to combine the sum and the multiple into one vector. I'm going to make my life easier for whoever's using this function by providing names to this vector. Right, so I can assign names to it, and I could do first one be multiple. Oh, that's backwards. Second one be sum. So we've got to fix that. And that's really going to confuse people. Let's do this again. Sum. Okay. Now if I run that function, I just give it two values, num1 10, num2 4. I don't have any problems, and it's going to return something sensible, a vector where I can see the sum, and the second element of the vector will be the multiple, and I can just get. So if I wanted to get my result back, I can then just use my named indexing to pull out the values of it. So you can't ever return, at least in base R, you can't ever return two objects out from a function. Okay, we need to wrap it up into a different object which can contain the values we have before we return. Okay, and that's where this potential object we saw earlier on, list, becomes really useful. Okay, so list is our container for all sorts of different types of objects, and I showed you when we looked at lists that a list can hold a vector in one element, a data frame in its second element, a factor in its third element. So here we could do something similar, and we're going to create some num, multiple num, input numbers. So I'm going to capture actually what was passed to the function. So first num is num1, second num is num2. Then going to create a data frame of our results. So we'll have one column called sum, which will contain the value of the sum. Another which is called multiple. That's going to contain the result of the multiple. And then in order to return a data frame and a vector together, it's hard to put that into one object unless I use a list. And this list is going to contain two elements, input and result. And the input's going to contain the input numbers we define here, and the result element of our list will contain the data frame we created. That then gets returned, and then when we run the function, we get two elements, one which is a vector, and one which is a data frame of just one row and two columns containing sum. We can just run that as well. In a similar way, we can now just access the elements from that result we really want. Here, I want to get the data frame. I know that's in the result element. And if I have my other element was the input. The lists are actually really useful for holding disparate data types, which can't be put into one object, like a data frame or a vector, but you still want to keep organized together. Right? So all these things we do in the function, we want to then return maybe a list. So on my cursor. So this really is like how we will write most functions. When we have multiple inputs, we will use a list. In a function containing a return statement, when you actually put this return in, and I'm going to show you, you can kind of avoid the return statement as well. But when you have a return statement in your function, the code will only run up until that return statement. Okay? Anything after that return statement is not going to get run, because the way the function works is it evaluates everything up until this return. And return is, you can think of the equivalent of break. Okay, it's going to say, nope, the function's over, I'm returning that object. And it won't continue down to any lines beneath the return. So return ends the function. So in this case, I've just put in a message to show you that we've got to this point. I put a message after the return. And we can see here when I run the function, same as before, I get the first message before return. And then it just, if I look at my result, I have it there. But I never got this message after return. And it's because when we ran the function, it got to here and it did exactly that. It returned the result and it ended the function. You don't always need a return statement. I think it's good practice to have a return statement if someone's going to read your code. But actually, what will happen if you don't include a return statement is the last line of your code will be what is returned out of the function. So in this case, usually I would write return list to return. If I just have list to return as the last line, it's going to pass that back out of the function. Okay, so I don't need to officially write return. For readability, I recommend always including this return statement. It's just a feature of R, you don't need it. Okay, so exactly the same as this one. I just leave that without the return. What more have we got on functions? So the important thing to kind of understand about functions, and this will haunt you in most programming languages, is this idea of scope. In scope, we really mean what can be seen inside the function. Right? When we're evaluating the function, what can R see? What's available in terms of objects? And when we talk about scope, when we think once a function's run, things like whether this some num variable here is actually available outside of the function. So I can really show you this in action. We have this function here. Let me just run this. If we look at this function, we can see it takes 2 arguments, and inside the function, it creates this variable sumNum. Right, and then that is what's returned. So if I run this, see at the moment we have no object available to us called sumNum. If I then run this, if I then run this function, I can get the result from it. I change that. You know, whatever's happening inside this code is being evaluated. Right? But now if I try and look at sumNum again, you can see it's not available. And that's because when I run a function, anything created within this function is transiently existing. It's only existing when the function is created. Okay, so that actually creates something where we have to be a little bit aware of. If I set sumNum now here, right, sumNum does have a value. I run this, I get my result, but sumNum doesn't get updated. Right? SumNum exists just outside the function. And when we run the function, anything created within here is just destroyed as soon as the function finishes. So you can't bank on anything you create in the function being available outside the function. Backwards, though, it's a little different. Anything which I've created outside the function, so here, if I create my third number, and I do that before the function or outside of the function, R will actually be able to read this object. So when you run the function, it's actually going to be able to use it within the function. So let's see this in action as well. In this case, if I run this now, and I haven't defined my third number yet, I haven't defined this. I run this function, it should give me an error. And it says my third number not found. And that's because I've got something in here, my third number, which I'm not declaring as an argument, so it must be coming from outside the function. If I now define that, and I run the function again, it's going to work. Right? It's using this value outside the function. This is really bad behavior, and you should never do this in your programming. We should always be passing this in here, because the problem is the function changes depending on the context of the R environment. Right? So if I was to change this, run this, my function will then start to give me a different result. Okay, so that's a problem. Really, we want everything we're going to use inside the function defined as part of these arguments here. I guess this is a similar thing here. If we have something defined above the function, like my third number, and then I redefine it within my function, it follows the same rule as here. Right? Anything changed or created within my function does not affect the world outside my function. So here, if I set my third number to be 4, and I change that value inside my function, and then I return it, the actual my third number doesn't change outside the function. It's only transiently altered within the function, and once this function finishes, everything's returned back to its standard state. There is an opportunity, though. There are the abilities to change the global value from inside a function. To do that, you have to use a special accessor, which has this double arrow, effectively. Right? So if I really want to change my third number, let's actually do this. I just need to use the double assignment. And when I do that, it's telling it to change this globally in the greater R environment and not just within the function. So we can kind of see that in action again. Let's do this. So I run that. So we've got 10. If I change this to 19. Oh, sorry. Back to 19. You can see my third number must be 24 because it's returned inside the function. Comes out 24, but actually my third number here stays the same. If I change this assignment here to double, my third number is 19 now. When I run this function, it should update my third number. So very rarely you will do this. You can change things globally from inside a function by using this double arrow. Really useful is that arguments can actually have defaults, right? So previously when we've set this function argument, we've just given it the names of the arguments num1 and num2, right? But there's no default argument there. If when we build the function, we actually assign a value to this argument here by doing equals 1 or num2 equals 3, then we actually don't need to provide any arguments here. It will just take the default value for num1 or num2, which here is 1, here is 3. And when we run my function, it's going to do num1 plus num2 plus whatever my third number was at the time, and it will return that value. If I want to set new defaults or new values for these, I can just assign the values I want, 3 or 4, and it will override whatever was the default here. I'm going to show you that in action again. To get rid of this third number nonsense. So the default we have 1 and 3, so the answer should be, without any arguments, 4. If I change the defaults, and the result, the answer will change. But what's nice is I can also provide my own values for these arguments, and here I could say num1 equals 1, num2 equals say 1, 2. I could actually just supply one of the arguments, and the other one will be the default. So if I do num1 equals 1, I will override this argument here, but num2 will stay as 3. That is the default. I run that. Should give me 4. And similarly, I can change num2 to 1. Now give me 6, right? 5 is the default for num1. I just set num2 to be 1. And then it's 5 plus my reassigned 1. So sometimes it's really useful to have default arguments because there are sensible values you can set up front for a function. So if you're like searching directories, maybe the place to start would be the working directory. So you might set that as a default for a directory. So then we have just an example function. This is one I think we'll use later in the course. Just putting this together now. So in this case, we have an argument which takes 2 values. 1 is a single value, 1 is a vector. And then it's just going to take the mean of your vector, print out a message for what that is. It's going to do the difference of the mean by your first number minus that mean. It's the standard deviation of your vector, and then it will take the difference divided by the standard deviation. And effectively, this is a Z normalization. So this is what we use in, say, heat maps and RNA-seq, way of kind of standardizing your data. In this one case, it's actually just returning one value. It's just returning this value here, my Z. So quite an easy function really to run. Right here. Okay, so my Z score takes 2 arguments. There are no defaults here, so we always have to supply values. I'm running this function rnorm. If anyone doesn't know what rnorm does, it's kind of complex. Effectively, rnorm generates random values based around the normal distribution. So we have a vector of A, and then I just take the first value as my number. It's vector, obviously. Prints out this message, mean is this, and then it returns the value 0, minus 0.18 as my new z. So we can create functions and make them as complex as we want. We can give them multiple arguments. We can give them defaults. But we can only ever return one object at a time. Okay. So there's lots of debugging options available inside R. And I actually find this really useful if you start writing your own functions. And we have these two things, debug and undebug. You know, the idea of bugs in code is when something just doesn't work or gives you a slightly strange result. So I've just run my z-score, just created this function. If I tried to do something strange, it's going to give me an error. Okay. If I want to know what's going on inside that function, I just type debug, and I give it the name of the function I want to debug. So here's z-score. And now when I run this, it's going to step through every line of code one at a time inside my function. This is really useful if you've written a complex function. You don't know what's happening when it's not working. So let's go step through it. So the first thing it does is take a mean of my vector, so I can look. I'm inside the function, so these are available to me. So I can look at my vector, it was 2. I can look at the result of my mean, maybe. I need to run that line first. So now I should have my mean. And I can just step through this to find the line which breaks. And if I looked, I know this line's the line which is going to break. Okay. So I'd step through it again. Why didn't that line work? See, my mean is 2, but my number 4, and that would tell me, somewhere there I shouldn't be doing 4 minus 2. Okay, so this idea of debugging just allows you, either with your own functions or functions written inside packages which you're making use of, you can just step through line at a time and just see what's happening inside your function. After a while, though, that's going to get annoying because it's going to keep on debugging this function. Eventually, you'll work out what's wrong. Now this is going to work, but it's still going to debug it. When we want to stop debugging a function, we just need to do undebug. Now when I run that, it just does this. I'm not sure why I'm getting NA now. Oh, because there's one value. These are useful, debug and undebug, and especially when you're using other people's code, because usually you can work out what's wrong with your own function. But if you're using these big functions or code passed down to you, it's okay just to look at the function and imagine what's happening, but debug actually takes you into the function and shows you what's happening. I think the last thing I wanted to show you here is that the real use of writing these kind of functions is then we can use these functions now with things like sapply, lapply, and the apply function. So here I can actually get the z-score for every value in my vector by just passing it the function my z-score and telling it my vector. So the second argument for my z-score, my vector here, I can supply that after the comma, just give it this additional. So what it's going to do then is sapply will apply my z-score to every value of A, and the additional argument we're passing is my vector. So we'll just go through and apply for every value. It will assign my number for every value of A, and my vector will be A for every. So that's custom functions. And again, you're never going to need to write a custom function for this course, but they are useful as part of programming. We've got some examples and some questions now coming up. So if you have anything outside of what I've said here, just ask me and I can help. Okay, so we can write our own functions, but a lot of the time we're going to pick up functions from libraries written by other people. Okay, so libraries are just collections of functions which have been organized such that they have documentation and they have tests. Okay, so we know they're going to work and we can see how they work. They can be loaded into R a number of different ways, but let's have a look at it in kind of the RStudio way, and I think we've done this already. So if I look here on the side, I have all my packages available. Okay, any packages I've loaded or installed will always be here. Hide some stuff. Like that. So we can see a description of what the package is. We can see the name of the package, and we can see the versions here. If you want to update or delete a package, you can do that actually within here as well. I don't recommend this. You can also search packages here. If I want to see if I have this ggplot package, fantastic. And then it should take me to a link here. If you actually click on the links by the package, it will take you to the package's homepage. So ggplot is something we're going to cover in our next session. It's a graphical package, and you can see it has all the descriptions on how to use it. Has all the functions described, and then it should have some manuals on running through and trying a few basics. If I want to load a package into R, the standard way is to do library, and then just the name of the package. And when I do that, it will load that package, and now all the functionality inside ggplot, all the functions are available to me. You also see it will become ticked here, means it's available. If I click this button, it's going to detach the package, and no longer can I have access to the functions. Similarly, if I just click it, it loads it, and all the functions are available to me. Easiest path. I think if I click this, it takes me to the help page. Okay. Yeah, we can see what packages available in the packages panel. I think if you're on basic R and you just type library, it gives you a list of all the libraries you have available to you. I think because we're in RStudio, for me it's much easier just to use this panel here. We can install packages through RStudio, or we can take advantage of this install.packages and then name a package we want. So if we do tools, so one is this one, install.packages, and then we just put in here the name of the package we want to install. So I think I put hmiss. One sec. So I went and just got that package. I'm going to trying to think of a more obscure package. I think I've got every package I want. Maybe I could show you this a little bit. So I just wanted to show you something, and I've installed a lot of this, but so it's a little harder for you to show you. Yeah. So when we actually, this is a CRAN page. So if you notice there, underneath the hood, when we do install packages, it goes and points to cran.rstudio. Right. So CRAN is the repository for packages for R. If you actually go to CRAN, they'll always have a page like this. So if you just Google this and you come to CRAN, an important point for what I'm saying here is that packages themselves depend on other packages, right? So whoever wrote ggplot has actually written a ton of other packages, and he makes use of them, but he also makes use of other people's packages, so he doesn't have to write everything himself. If you were to create packages, you're not going to write every single base functionality. You're going to take advantage of other tools people have written. This means, though, that in order to install this ggplot2, I also need to install digest, glue, grid, ggtable, isoband, mask. All these need to be installed too. Okay. And actually, I think by default, it's going to try and install all the suggests as well. Okay. So it's going to try and install all these packages so that you can make use of the functionality inside this. What is fantastic, though, is that we don't have to worry about that. This framework, it will check, okay, you've got ggplot needs these packages, I will install them too. If those packages need packages, it will install those, right? So it's going to build this graph of dependencies and take care of that for you. And this is something I can tell you in R is a real boon, because it doesn't exist in a lot of other programming languages, and when it does, it's not particularly tidy. It's not as tidy as this. To be fair, CRAN is based on CPAN, and that's Perl. But they've done a really good job of maintaining this ability to install packages and all their dependencies. So we didn't even have to worry about that. If I do install packages, sadly, I've already installed these, so I have their dependencies. But if you installed, say, HMIS, if you run that line on your computer, you will watch it install probably 10 or 20 packages. Right? And those are the dependencies for that package. Okay? So it handles all that for you. We're going to show you an alternative to install packages later. You don't need to know that. This is the base R at the moment. If you do this through RStudio, I think it's even better. So tools, install packages, repository CRAN, so it's the default. And if I start typing HMIS, you can see it's like searching. It has a repository of CRAN there. So I can do a free text search until I find my actual package of interest. Just click there, install dependencies by default. I've already just installed this. Okay. One thing we might want to do before, we're not going to cover package development in this course at all. I think Matt at some point was kind of excited to do that, so that still might come. But really, once you started building your scripts up, your functions, you want to take advantage of them. Right? If you build your really useful function here, zscore, I want to be able to use that in my code without having to type it in every single time. Sorry. So I don't want to have to copy and paste this into my R session perhaps every time. One thing I can do is source a script. Okay, and source a script effectively just runs that script. And if I run a script which has all my function definitions in, that means I just source it and all those functions will be available to me. So here, you can just do source, and you can see it runs it, and then it's all available to me. If I want to source a script on the command line, I can do source, and then I just tell it the script I want, and it will do the same thing. Okay? So you can source your particular script. You have all your functions, your functionality in at the beginning of your session, and then just take advantage of all your. Okay. I think we've already seen this, but in RStudio, if you want to save, obviously file, save as, and it will automatically, if it's called .r here, it will automatically save it as an R. You can also open files. I'm not sure if I've already shown you, you can save your workspace. Right, so save workspace as. So there's a difference between saving an R script and saving a workspace. I do Tom's. Save that now. Tom's workspace will then contain every object which I've created in my current workspace. So I open up a new R session. Do load workspace. You saw there when I loaded it, all these values popped up all of a sudden. And that's because by loading that workspace, anything which was in my current environment, all the objects I created, all the functions I created, were then saved in it. So even the functions, I didn't need to source anything. Everything got carried on. Notice this saves all objects in your workspace. Yeah, we just saw this, that we can source scripts. The last thing I want to show you, and I'm not sure how many of you will do this, but right now we're running R interactively. Okay, so that means we open a session and we type our commands. Okay? You don't need to just run R interactively. Once you have created your script, which perhaps reads a file and then does some process to it, you can also just run scripts by using this R script command. I'm going to see if I can just get that working here. So if I run R here, we get R. So this is the terminal right inside R. If I run R script, it gives me like a set of arguments, etc. But it's not opening up an interactive R terminal. So when we run our script, we also pretty much always want to give it this option -- vanilla. And that's because by default, when you run R, whatever's in that directory, it will try and load your workspace. When it quits, it may try and save a workspace. So if we just write -- vanilla, it's basically running R with no defaults, no arguments. And then we just give it the name of the script that we want to run. Okay, so let's try that. So I should be able to do -- vanilla. And hopefully, so that ran R non-interactively. It evaluated this script I've just written, and that script had one thing to do in it, and it was to add 2 minutes. So this might be once you've built your complex script up, you don't want to run it interactively. Maybe you put it on your cluster to run at a certain time. You would use R script and then just pass it the name of your script. Another way of doing this is actually R command batch my script. And I think the nice thing here is it just kind of captures the error messages in a slightly different way. So let's do that too. I've got anything here. Yeah. So notice nothing got printed to the screen. Instead of doing that, it actually created a out file called the same name as the script I ran. Right, and here it is. And if I look in there, see, basically it captures all the information that was running in R, including the startup. And then it's got the little script bit I ran, and sort of just telling us how much time it took. So R script -- vanilla or R command batch can both be used to run R scripts from the command line without having to go interactively. So the last thing you might want to do with an R script, right, is if you're not doing it interactively, it's hard to give it arguments or functions. So actually you can add arguments to your script by just adding to the top of your script. Let's do this here. Args equals command args true. My first args 1. And my first arg. See if this actually works. So what it's going to do is capture this, whatever I passed after the name of the script. It's going to capture that, pass it to the args variable, and then I can evaluate and use that inside the script. The last part's about our script. Really, this is going to come back when we start to get towards actually running some high throughput sequencing and doing this a little bit less interactively. You really don't need to sit there while you align a BAM file. It's going to take 2 hours, right? So you want to run that on a command line, but interactively for your analysis and plotting. I'm not sure that last one quite worked for me, so I might come back for that in the exercise. So we do have some really simple exercises for functions. I'm a little early, I'm not that early. Again, we don't need to learn functions for anything else we're going to do in this course, but I recommend you go through these exercises. They are useful. And writing functions, if you want to start to write your own bioinformatics, is certainly important. Okay. So as always, we have the functions, the exercises here. We also have the answers here. So don't, oh look, we're making use of our previous kind of exercises here. We're just trying to wrap them back up inside functions. So it shouldn't be anything new in terms of programming. It's just putting it inside a function now. So I'm going to give you just under an hour, and we'll come back for this at 2:45. Is that right? 2:45. And then I'll do the last session today. So the last session today is going to be, I think, one of my favorite sessions, because we're going to do how we can turn our R code into beautiful interactive graphics and HTML reports. So I'll leave you for an hour or so now. I'll be in the room. David's at the back. And we might take a quick break now. But if you have any questions on anything we've just covered, let me know. We can talk about it. Stop. Pause my recording. Recording, that's the important bit. Sorry, from someone. Turn me off. Oh. So let's share my screen. So I think we were looking at functions in R. Okay, create a function which takes one argument and returns the square of that number. Okay, so really just the number to the power of 2. So we just do create a name for our function, square of number. That's the name of the function we're going to create. Assign to that the function statement. When I say it just takes one number, which means it takes one argument. We'll call that argument here number. So then inside the function, we take whatever that argument was, number, we square it, we return it to or we assign it to an object called square of number, and then we just return that. Okay, so when we run it, square of number 3, we'll get 9. So really we're just looking at building a very simple function, passing in one argument and returning just a single number. Create a function now which takes 2 numbers and returns the mean. Okay, so all we need to do here is have number 2, so we have 2 arguments rather than just 1. And then we need to pass them to the mean function, and then we're going to pass them as a combined vector. Right? So we just combine those 2 vectors and then take the mean of that combined vector. Create a function which takes 2 vectors and returns the mean. I don't think we need to change anything. We just change the names here, because the mean will accept either a single value or multiple values. It really doesn't matter. Okay, so we didn't need to change anything to turn that to take 2 vectors. Okay. So then we get into the slightly more complex, and really this is just returning multiple things in one go. And the trick here is just to assign everything you want to return to a list and then return that list. So it's going to take 2 numbers and returns the 2 numbers. Okay, so we actually did that as one of our examples earlier on. And then it creates a data frame which contains the mean, summary, and multiple. Sum, I think I mean that. So we have our function, it takes 2 numbers, takes 2 objects. They don't need to be numbers, but they are. We then concatenate or combine them using the C function, and that will create a vector of our 2 inputs. So that covers the 2 numbers as a vector. And then we're going to create a data frame with a mean column, which is the mean of the 2 numbers, the sum column, which is just number 1 plus number 2, and the multiple column, which is just number 1 times number 2. So then we have a data frame and we have a vector. We want to return both of these. So we're going to return a list which has both the input, this vector, and then the data frame. Okay, so then when we get our return, we have a list of 2 elements. We could have named them to make it easier, but the first one is our input, 1, 3. And then the second one contains the mean, the sum, the multiple. Okay. So these answers here, we should have already covered like how to do this factorial. So if we do find smallest factorial, we're going to create a function which takes one argument and finds the smallest number whose factorial is greater than that. Okay, so actually this is just a rehash of one of our solutions we had previously. We go here. So actually this is the adjusting your answer before. What is the first number that has a factorial greater than 1,000? So what I would have done is just copy this, come to my R studio, sorry, R session, file, email. So I would have made that my starting point. I need to find the value. So in our first exercises, we had a set factorial greater than 1,000. Our new exercise wants to have this as the option. So we need to be able to provide a number there. So let's go back to our actual exercise. It takes one argument and finds the smallest number whose factorial is greater. So we just need to be able to basically replace that x with a user-defined number. So let's wrap all this in a function. Takes one argument, so we'll call that number. Wrap up the whole thing. Need to return the result, so I'll do return count. And then I'm gonna make that now the option. So I can actually specify the first number, it's got to be greater. Okay. And then a really useful function here, if anyone doesn't know, if you select some text and you want to kind of indent it and make it look a bit prettier, just select it, Command I. This makes it a little easier to read. And that should be our solution. As is here. We just change this number here from 1,000 to X. I put number in my solution and then X here. Importantly, we need to return the count. So we actually have the result back from the function. And add an if-else statement in your function to your only calculate factorial code if argument is there. Okay, so we just need to check. We need a way of assessing this. I think we saw this in our first session. If we have a number, we can check its class. So 1 to 10. We can do class X. It's going to tell me it's an integer. We can also do is dot character. It's not a character. But what we're really interested in is whether it's a numeric. So whether I can do sum, mean, or whatever to it. So we can use this is dot numeric to assess whether or not something is actually a set of numbers. If it was a character, then that would be false, but is dot character would be true. So in this case, we're just going to check, have something which is if number is dot numeric. Okay, so that's going to assess to true if it is numeric. And what I can do is, if it's not numeric, I can do message not numeric. I can do something like break, stop, and just break out of the function. Or I could do that the other way around, and I could say, if it's numeric, actually run everything below it. And if it's not, it's just going to do nothing. Just to give us a little bit of, this is a, when you write functions, occasionally it's nice to think about your user and just to capture some times where you might do something stupid. In this case, you might put a character in there. This is just going to check if that number provided, the argument provided is numeric, then enter this section and actually perform the calculation. If it wasn't numeric, it just skips over and it won't do anything. Okay, so that's functions. And remember, we don't really need to cover much in functions, but they are useful. I think one of the best examples there is actually this one, where the way you're going to write a function is you'll get it working on your one piece of code, your one file, and then you'll change your current bit of code. In this case, say this one, we just replaced X, right? That was 1,000 before. I now replace it with X. That's my argument. So turning your scripts into functions is usually the way you go about it. You write it up front, you test it on one example, and then you turn it into a function. Okay, so that's everything we'll need to know about basic R. To cover everything in this course. You don't need any more complexity, but trust me, R can get very complex. But everything at this point, we know how to deal with data frames, we know how to deal with matrices, we know how to make some loops and conditionals, so we can do everything we need for high throughput sequencing analysis. So one additional thing we add to this course is this reproducible reports. Everything as usual is available on the website. So if I just take 2 steps back, this is the website. Download the material, please do. And for this, we're going to follow along just this reproducible reports first section. Everything in the usual place. Okay, so this is Donald Nutt, I think it is. Maybe it's Donald Knuth. I should look up how to pronounce his name because we do this talk every year. And this is back in 1984, and he did this book, Literate Programming. And actually, literate programming in itself isn't too popular. And effectively, it's the concept of, let me quote it here, let us change our traditional attitude to the construction of programs. Instead of imagining that our main task is to instruct a computer what to do, let us concentrate rather on explaining to humans what we want the computer to do. Okay, and really, he wants to set out to make sure that for every bit of code he's writing, it is easily explained and the user knows what your intention was. Okay? As you start to write your code to analyze your data, it makes sense that you're going to get this reviewed probably for publication. Even before that, you will be passing it to colleagues. You will be working with your PI, whoever's your mentor. Providing him with context to your analysis is essential. Reality, a really important point is that sometime in the future, most likely yourself, but it could be your successor, whoever is picking up your project once you've left and you're moving on to new ground, needs to understand what the analysis is here. Your reviewer wants to be able to probably pass it off to someone in their lab who is their bioinformatician, and they will want to go through your code. So using RStudio, we can make reproducible documents super easily. RStudio has built up over time, and one thing they did pretty quickly was hire lots of the people creating these tools to make reproducible documents. So before we get going, has anyone here ever used LaTeX? Anyone know what LaTeX is? Yes, David, I imagine you do. No, so this is like a way of preparing your documents. They're very popular for PhDs. It's different from things like Word, but it's like a programmatic way of creating your documents. Okay? So a lot of what we're going to cover here is kind of built on this, but so much more straightforward than LaTeX if anyone's actually done that. So let's see how we can make a very quick reproducible document in R. Just need to find the R script of interest. We're going to add a session info to it. So one line, one function. And then we're going to find this compile notebook function, and we're going to select HTML as the output format. So let's do that. Let's find the script, my first script. Let's change this. Let's create something. There you go. So we'll save that. I'm going to call that script. I should have a function here, and it's hard to kind of see. So if I just mouse over this part here, so we have code tools, and then right by it we have this button, compile report. Okay. So I've just got my very simple R script here, and if I click that, create a standalone report that contains the code and the output from your R script, and I can select report output format, and I'm going to say HTML. So somewhere there it did some work in the background, and then it compiled my script. I can open this up. It will be in the same directory. There'll be a script.html. If I click on this, I can either view it in my browser, sorry, inside RStudio, but already I can see it here. Importantly, code is here, everything I ran. Here's the output. Right, this is a very silly example. I'm just messaging the result, but reproducible already. Okay. Have to hop back and forward. So you can do that really quickly, right? We didn't actually have to do anything. We didn't have to do any thought. We just pressed one button, said OK, and it went and compiled our script into something reasonably useful. At least it covers our code and our message. Do you know what I forgot to do? I need to add session info. I'm sorry. I'll add session info to that. I said I would do that. I'll compile it again. So the useful thing about session info here, as you can see, it reports lots of information on the R version we're using, what operating system I'm using, but also the versions of the packages. So if I've installed a particular package and I'm making use of it, it says the versions here. So now I have my script. I don't just have the code, right? I have the result, but I also have the whole session info, all the version of R, the version of the library. So this is a lovely reproducible one. So, you know, RStudio makes this very easy, but we can have a fine degree of control. So that was one button, and we didn't really have many options, HTML. RStudio makes use of two packages, knitr, which is written by Yui Shi, and I think R Markdown, which is written by a few more people. But again, this guy, Yui, is an incredible bioinformatician, or at least incredible designer of these types of packages to make reports from standard bits of code. So he was originally independent of RStudio, but he is now works at RStudio, and he's brought the knitr and these R Markdown packages to RStudio, which is why they're just so well integrated. Several packages offer various methods to do this, but one of the simplest packages is the R Markdown. And because they're written by the same person, R Markdown and knitr, they overlap in their functionality, and you will use functions from inside R Markdown without really realizing they're just calling knitr functions. But one of the simplest things we can do if we want to recreate what we just did inside RStudio is to load this R Markdown package. If you don't have it installed, we know we can do install.packages, and it will go get everything. And then we run this render script. So I can do that here. I'll do library R Markdown. I'll do render, but I'm going to render the one we just made. So script R. See, it calls actually out to another program called pandoc. Then it's going to go create inside my thing. It's going to create that script. We don't need to use necessarily the RStudio way. We can just use the render from inside the R Markdown package directly on our R script. So we can just have a look at that. We've already seen this, and we've already kind of assessed what that looks like. The render function can take additional arguments, so we can specify the output format we want. So earlier on, when we did it inside RStudio, it gave us some options, HTML document being the default. If we wanted to, you will see we have things like PDF document, which is really useful because you can print it much easier than an HTML document, but also Word document. You know, Word actual document is easy to create. It's just a bit of XML. We can create that too, so that your thing is compiled and you open it up in Word and you can edit it. The additional arguments we can pass to this are output file and output directory. And this is just going to tell it, I want to create this name. So by default, when we ran it on scripts.r, in that directory, it created a script.html file. Right? If we want to name that HTML file something particular, we can put it inside the output file name here. And if we want to put it in a particular directory rather than the current working directory, we can also specify the output directory. So rendering a report with the metadata like author and date of render is obviously the first thing we want to do. So by default, it knows my name because I'm the user of my computer. So it just looks up my user, puts it there. It knows the name of the script we ran, and it knows the current working date. So that's by default we'll get for free when we write this. But we also want to be able to annotate our code. So we want to be able to have messages which aren't compiled, well, evaluated like our code, but perhaps describe to the user exactly what we were doing there. So in R, we can just add comments to our code, like a normal comment. And we talked a bit about this hash. This is the same hash which we skip when we do a comment.char in the read.table. Most programming languages use hash. When you put a hash in your script, like here, this just tells the compiler or the tool running it, do not evaluate this. Anything with a hash, everything after it, for the rest of the line, is not evaluated. So add a hash into here. 6 plus, so we'll break it. Okay, so that shouldn't work. If I try and run this bit of script, see, it doesn't evaluate anything with a hash, right? It just didn't evaluate it. Put it in the console, but it didn't evaluate it. You can do that. You can also just do that here. It's easy enough for us to put comments in our code. If we don't compile it, we can just look at them. We can look out for these things like this. If we want to include comments as text, once we do this render function, then we need to do something slightly different. And rather than just having a comment, we do a comment and then this kind of quote mark. All right, so let's try that. So I see what they look like when I compile them. That's clever. If in our studio, if you press enter, it fills in the quotes for you, so you can just carry on going. Okay. So now if I was to run my render on this, what does it look like? See, so here we have our bit of code, Tom, David, and then here I did this special comment char, which is comment with a quote after it. If we look in the actual output HTML, you can see that got placed as a normal bit of text in the file, right? So the compiler knew, don't try and evaluate that. Don't leave it as a normal comment. Place it as text. The other line here where we had this just normal hash got put inside a standard kind of code chunk. That's what these are called, these kind of code chunks, alongside this message afterwards. Okay, so if we want to include something there, and we can do multiple lines as well. Spellings were bad. Either way is going to give us the same result. Put a space if I want a space in my thing. We'll come to that in a second. Okay. So it's easy enough to add. My time. Easy enough to add both comments but actual text to our page generated by this. If we want to control all those things at the top, we actually need to do something kind of complex. We need to insert some metadata. Although I'm showing you this line, I'm going to show you a much better way of doing this in a few slides. So if I just copy and paste this, maybe let's see if this works. We'll come back to YAML later. So YAML is just a way of organizing information. So if I just paste this at the top, I wonder if that works. So what information have I got here? Title, author, date. Oh, so now the date's not great because I put text in there, but my title got updated. BRC making notes, the author got updated, and then this date. Let's do it again. So we can control, to a fine degree, not just the comments, the text, but we can also control the title and the space. Although we haven't come to figures yet, we will do very soon. We want to control also how these look inside our document, right? And one of the first things and most important things we want to change about our figures is their size. You don't want these tiny figures conveying lots of information. And you don't want a figure which is so big it's off the side of your HTML. So we can control that with a slightly different special type of comment just before we make our plot. So if we want to, we can not just do this comment quote, and that will give us text. We can do comment plus, and then we can provide two arguments here, figure.width, I'm going to do equals 3, comma, figure.height equals 3. And so this will be in inches in this case, and it's just going to be set the figure width to be 3 and the figure height to be 3. Often maybe you want figure height more depending on your plot. So we haven't actually run any plotting yet, but I just want to show that in action too. Do that here. And then I'll do, where did I get my figure there? Okay, so there I get my histogram. And if I want to change the size of this histogram now, I should be able to say figure width, give it 15. And do it again. Now you can see it's really wide. So this is how you can control these things just in your standard R scripts by adding a little bit more information. Okay. So now that is great, right? We can do that inside R, but in the actual under the hood, R is doing some work for you, and it is making use of a fantastic bit of document preparation, and that is Markdown. Okay, so we know markup. HTML is a markup language. LaTeX is about markup. This is a little play on words here. This is Markdown. And I first came across Markdown a while ago, just as I was trying to build the pipelines for Cancer Research UK in Cambridge and UK. We were using lots of tools to kind of move between R to PDF documents, and then Markdown came along, and this tool called Pandoc, and effectively from Markdown, I can go to PDF, I can go to HTML, I can go to Word, I can go to so many other different formats. And that was really the beauty of Markdown, is it was this intermediate, which allows you then to shoot out to hundreds, if not thousands of different formats. Okay, so even though it's called Markdown, it is a markup language. Effectively, it's plain text. You can just read a markup. It's not like Word where it's binary or something. But there are elements within this document which mean things. Okay, so a quote may mean something in Markdown, and it will get translated by our tools, which make our HTML from. Okay. So it is kind of an intermediate document type. We create first our R script, then we create Markdown, and then we ran. And if we look under the hood, RStudio is running this pandoc. Pandoc converts the markdown. Script knit.md markdown to a HTML file or whatever we specify. Okay. One place you're going to see markdown used very heavily, and actually it's used in a lot of websites. And you can just write markdown. In fact, I think OpenOffice supports markdown as well. So not OpenOffice, Outlook supports markdown. And it just means that if we look inside the actual code, you know, in this example here, on GitHub, there will be something called a .md document, right? If we download that, you'll see it's text with descriptions, etc., like we just did. GitHub instantly changes that to a readable document with titles, with, say, lists here, bullet points, links, you know, code chunks. So actually, Markdown itself is used within other tools in order to like help, you know, have their documentation. So actually, Markdown, I think, you know, last thing I'll comment on that. Markdown was actually created by a New York native, Aaron Schwartz, who is, you know, you may know him from Reddit. He's creator of this. He's an amazing guy and a real advocate for online open source. Okay. So this guy gave his life for it. And if you really want to watch, and I recommend watching the story of this guy, the internet's own boy. It is a sad story, I warn you. But this talks you through the whole Stanford problems. I think it was Stanford, MIT maybe, where he basically tried to download all the journals onto an open source place. He got caught, he got sued by the FBI, and he went and took his own life. But he's the creator of Markdown. You know, he's brought a lot to open source, and it's certainly worth knowing the man behind it, Aaron Schwartz. Gordon, Brooklyn. So Markdown uses very simple syntax to control text output. It allows for the inclusion of different font styles, text structures, so lists, numbered bullets, etc., images, and code chunks. So as we saw, it has a special way of displaying code. And then on top of that, it can do syntax highlighting of your code. So you can read your code quite easily. So Markdown is written in plain text, and it ignores new lines. To include a new line, end the previous line with at least 2 spaces. Okay, so that's a little bit of a trick. Let me show you. I'm going to have to hop back and forward a little bit between the thing. So let me try and make a new file, and I will try and make a Markdown file. So this is for Markdown. And do this. Test. If I just start a new line, I just press enter. And maybe go start. I preview that. You can see it just puts it on the same line. So RStudio is ignoring the fact it's a new line. I can kind of cheat that by just adding another line in between. I'll get a gap. Or, as I just said there, I should be able to add 2 spaces here, save that. So if you end a line with 2 spaces, Markdown will know, okay, the next line is really a new line. If I get rid of those 2 spaces, when it compiles this, it's going to put it onto one line. If I leave a gap like this, it's going to create a new paragraph. I'm going to have to hop back and forward a little bit between Markdown and RStudio. Emphasis can be added to your Markdown documents, and I think this works in Outlook as well, by either adding an underscore around the word or a star, I guess we call that. So if I want to make italics, I can just put underscore, start the word I want in italics, and then end with an underscore. If I want to make it into bold, I can do double underscore or double star, and that will create a bold and italic one. So let's say I got my Markdown document somewhere here. And I want to make Tom bold. I can do 2 stars around it. And now when I preview this, you'll see Tom here is now in bold. I think I can do this across multiple lines. So if I do stars and then stars there, nope, I can't do it across multiple lines. Let's try the other one where we just do 1 underscore, and that should make it italic. Yep. Okay. We can do a little bit of text styling that way. If we want to include figures, external figures into our markdown, that's very easy to do. We just need to follow this kind of format here where we do exclamation mark, and then in square brackets, we do the text which will go under your image. Right? This is the caption. And then we'll do parentheses, and then either the path to your image on your own computer, or Markdown is quite good if you're compiling it into HTML. You can just do HTTPS // and then the actual path to it online. And it will go and download it and insert it into your Markdown document. So it's always going to follow this kind of format: exclamation mark, within square brackets the caption, and then within parentheses the actual path either to your local computer or on the internet. You can also do section headers inside our Markdown. So if we want to have, this is the paragraph intro, this is methods, this is description. We can add headers to our Markdown by using normal quotes. And this is Markdown now, so normal comments. So I'm just going to do it like this, compile it, show you. So right, if I do 1, it's got a really big title. If I do 2, it's a slightly small title. If I do 3, I have the impression it keeps on going for a while. Maybe I'm wrong. I think there are 7 levels of headers. But I could be. Yep, just get smaller and smaller and smaller. So we can have sections based on headers using just a normal comment char. And the more comment chars, like the lower level header it is, the smaller the header. We can also create lists in Markdown. So we can do kind of hyphen, and then the first element, and then we can do hyphen, and then the second element in my list. If I want to do nested lists, I have to do tab, and then I can put a plus, and then whatever items I want to put. Okay, so that's then gonna render this like you would a standard kind of bullet point list. This is my first item, this is my second item, and then underneath my second item, I have my sub list. See that in action. But we also do numbered lists. Okay, very similarly, we can just do 1.2, and that will then get compiled into a numbered list. 1, 2. In Markdown, text may be highlighted as if it's code by placing the text between apostrophes. Okay, so I think that's what I mean here. So let me try that. So let's say by 6 + 7, I try and preview that. You can see it just comes out as like normal text, right? 6 + 7. This is Markdown. There's no R in this at the moment. This is just standard Markdown. It's just a way of displaying information, text. But that's not really how I would want it displayed. If I want to make it look like code, format it into a code block, I have to do these 3 quotes, apostrophes. If I just put those around my bit of code and then I preview that, I'm going to put it in what is called a code chunk. It's like a little box. And this then just highlights that this bit is code, it's not common. And usually people will go and select that. So just by adding these 3, and anything in there will be code. Okay? But nothing's being evaluated. This is just how to make your text look a certain way. This is just Markdown. Okay. I often use Markdown though for my presentations. All our presentations we're showing you, the whole of this course is built in our Markdown. Everything we show, all our pipeline outputs, it's all built in our Markdown. You can make slides, single page, and that's what's really cool about it. From one document, I can make the presentation, the PDF, single page HTML. We can also add HTML links to our page. And I think just by copying a link into Markdown, it will recognize it's a link. But more explicitly, we can do something similar to what we did for the image. We do a square bracket, and we have the bit of text which we want to highlight as a link. So here, GitHub site. And then in the circular brackets, I put what I want that link to point to. Okay, so let's try that again. So I'm going to do it like that. And if I preview this, I should just have the GitHub site is what the text was. It's what's inside the square brackets. But what this GitHub site, you can see it's a link. If I click that, it's going to take me to our buying. I actually think our studio will often just, so if I just put in a straight link, it knows to add an actual link to it. So if I just put in an HTML page, but I've lost the name. We can also add page breaks to our thing, and this can be useful when we just decide this is the end of our chapter. So a page break is this. And so if I add that into my document, it will know when I compile it into something appropriate where we have page breaks. It will then make sure to put a page break. I don't think we get page breaks in HTML, but when we make PDFs, it's going to know to put it onto another page. Okay. So this is Markdown. It's just a way, you could use Markdown to create standard Word-like documents. It's just a way of effectively writing text, making it look a certain way of formatting your text. So R Markdown is everything which we get from Markdown plus the R engine inside it. Okay, so it acts as a script type used in R to allow the generation of Markdown and R code. Whereas our other Markdown documents just were .md, an R Markdown document is going to be .rmd. So R Markdown really extends Markdown syntax to allow for the inclusion of chunks of R code. That R code will then be evaluated in the result put inside the HTML page PDF. So what we were doing just now with the script and compiling in HTML, R Markdown allows us a much higher level of control. A really useful thing is that it means we're going to be able to integrate the results we give to people with the actual code used to generate. So the knitr package is probably the main route to create documents from RMD. And knitr was created, as I said earlier on, by Yui Shi. And it really wraps up and cleans up a lot of the issues we were having with dynamic documents in the early days of R. So this transition from R Markdown to R Markdown is really simple. We don't need to do much. We just need to revisit the code chunk thing we were looking at earlier on. So if I wanted to make this into an R Markdown, the only real difference in syntax is this code chunk here, which wasn't being evaluated. It looks like code. If I add after that curly brackets and put in R, that then means that this code chunk will be evaluated by the R engine. So I'm actually going to create, an R Markdown document. So if you've installed R Markdown, let me show you this. When we do File, New File, one of the options is R Markdown. So rather than just an R script, I just type in my title, test. we can already see that it's filled in some parts of this for me. So I'm going to simplify our lives here a bit. But that's the markdown code chunk there for this. 1+5. So this is the little bit of things which will look like code, but now I put R here. It's going to be evaluated as well by R. And what I was describing about having this YAML to control your title, when I load the R Markdown default, it puts that YAML in for me. So I don't need to think about it much. All I need to do now is go here and change bits limit. So I can do the same as before. I'm going to click this knit button, result. Go compile there. It gives me a title, new test. But now this bit of code here isn't just represented in a code chunk, it's also evaluated and the result put directly under that code chunk. Could just make it more like Markdown, remove the R, and if I knit that, you'll see we just get the code chunk. By adding this curly brackets R, it's telling it to evaluate this part as R. Okay, so then we can start to control. Let me have a little look about what we're going to cover. Perfect. So we can control whether or not we actually want to evaluate code within a chunk. Okay. Sometimes we just want to show people what the code was without actually evaluating it. We can control that by just putting after the R a comma, and then we're going to have options which we can use to control how that bit of code is run. So in this case, I can write, it's this one. Great. So in this case, I can do comma, and then there'll be options. And already RStudio has pulled up all the options available to me. And one I wanted to use was eval. And I'm going to say eval equals true, right? So that's the default. If I knit this, I get the result. If I say as eval equals false, it's not going to actually run the code, but it's going to show me the code. Okay, so I don't get the result of it, just get the 1+. That can be useful if you just need to show someone, but it's going to take hours to run that bit of code. As like an opposite of that, we also have this argument echo. Okay, so echo is going to control not whether the code is evaluated, but whether the code itself is actually put in your R Markdown. And it might be that you're trying to produce a document which you just want to be pretty and present your results, but not necessarily put in long bits of code in there. So if we then adapt our present one now, we can see, I'll put that back as true. If we evaluate that, we'll get the result and the code. But if I add an additional bit, echo equals false, you see now I don't see the code, I just see the result. R can actually produce a lot of warnings and messages when it's doing things. So some of these warnings are absolutely valid, but you've already understood them and you don't really want them printed into your document. Also, when you load libraries, you'll see that they print a lot of messages. When I load ggplot, it tells me information about my environment. In that case, I might want to suppress some of these messages. And some programs can be very verbose. My document, I might want to keep concise. So we can turn off warnings and messages additionally by just adding after the comma, warning equals false, means I won't get any of these warnings. Messages equals false. Okay, so let's try and put that into action too. And let's try the message one. So message, so I got my message here. If I knit that, it's going to say Tom should be able to suppress that by message equals false. Okay, so I said in my first few lectures, don't use print, use message. And this is the reason. Messages can be controlled at a higher level. I can turn messages off here. I can't turn print off here. So if I put in my code all messages, if I want to silence it, and I'm running it as R Markdown, I can just put message equals false. If I put print throughout it, there's no chance of me just turning it off at 100. Yeah. That's my mom. Okay. So we saw that we could control figure width and figure height, right, by using this comment plus. So here we can do something similar, figure width or figure height, by just specifying them inside the actual top of the R chunk. So we haven't made any figures yet. Make one just R norm do figure. That makes it easy for you, RStudio, because it fills in the rest of what we need. So here, figure height, I'll do 5, and then figure what? There you go. 7. This is both annoying and friendly. So the R code within your R code block can be reformatted using the format R package. This can be automatically done when the tidy option is specified. So R has got packages which will work to tidy up the code you already have. I think this is actually done by default. So all we could do is split this up. You know, and if I'm writing code in really unfriendly ways and it just looks ugly, if I knit that now, I'm not sure if it's gonna. Oh, I gotta actually show the code. Echo equals true. So let's try that tidy equals true. Yeah, that didn't work at all. I guess it doesn't want to tidy up that bit of code for me. That's disappointing, but I'll come back to that and hopefully I can fix up and make that a little tidier. I can tell you most of the time RStudio forces you. It will try and tidy up your code in your code chunk. So you'll rarely get this. I suspect I've set something for this course, which is stopping it tidying. So what it would normally do is take something like this where you split it across multiple lines and it will just put it back onto one new. This package tidyr, reformat R, sorry, has built-in functions and understanding and rules about what code should look like. So I'll come back to that bit. A really useful function, mainly for like if you need to save space a little bit and just the way you want to kind of display it, is this collapse equals true. So what collapse equals true is actually kind of combines the way your output and your kind of code and the output from the code kind of looks. So let's let me get rid of all this. Collapse equals. I'll just do this, get rid of that bit. So this should be kind of standard. I do collapse equals true. You can see basically it puts it all into one little code chunk for you. So it makes it look a little bit more like base R, but it keeps it in a code chunk. The really useful thing about that, apart from just display, is, you know, this takes up very little space on your actual page. Oops, sorry, that's useful. Whereas once we do the collapse equals false, you can see it takes up multiple lines and it's got spacing around it. So often when I'm doing presentations and I want to present a bit of my code and stuff, I might use collapse equals true. effectively just puts it all into the same code chunk, both the results and the code itself. Yeah. You can also like have really nice tables inserted into our HTMLs. So one thing is we can use the knitr function cable. We just need to set the format out to markdown, and then it should give us a nice kind of table within our HTML documents. If we look here, we can see this is kind of what it looks like. We just create a data frame, and then if we cable format equals markdown, it should create a nice little table suitable for being in an HTML page containing our results. Hopefully I'm going to show you the data table too. Start a new one. Need knitr installed library. So cable comes from the knitr package, so I know to load knitr. So it's kind of created a table and put that into our HTML, which is just better than printing a table to our HTML. So when you've got data frames and you want to show them in a reasonably sensible way, you can just use this. Okay, I want to show you, it's not on the slides here, but I do want to show you a slightly newer functionality. And another really nice package for putting tables inside your things is data table. It's a JavaScript library. And it's actually within this DT package. So if I load the DT package, I should be able to run data table and then give it the same kind of object here, df itself. So let me make that a bit clearer. So here I'm using another package, the data table, DT library. I just load it and it has a function called data table. I give that a data frame and it should put that in a nice format, which we can then review inside our. So here we go. So then this is much more like an HTML table, right? It's made it sortable. It's given us options to filter how many we want to show at one time. And it's also given us a little search box as well. Okay, so just 2 lines, I can turn my data frames into searchable HTML tables within my reports. So see how much more we got to go through. It may be useful, actually, if you really are going to do this properly, this is actually kind of an essential. You can evaluate bits of our code actually within the text. And to do this, we just need to do a slightly different way of including code. So let me try. Number, spell anything is it's this R 6 plus. See if that works. In this case, I just do 1 apostrophe. I can just tell it R. So it needs to know this is the R engine. And then anything after that, up until the next apostrophe, will be evaluated as if it's R code and then inserted back inside your page. So in this case, my favorite number, it evaluates 6 plus 9, and that's what got put. So we can do kind of inline R within our document as well. And that can be just useful to give things like the date. What's the word to do? Date. Sys.date. I evaluate that. And I can now put the date inside my pages. Sometimes when you start to use R Markdown for really large pieces of work, and high throughput sequencing, there are parts which just take 40 minutes to normalize your data, to do long operations on it. you do not want to wait every time you compile this document. Remember, you might just change the text, but you're not changing the code, right? Every time you press compile, all the code is evaluated again. So in this case, we can just press cache. We can add an additional option, cache equals true. And what it's going to do is check when we run this document, has any of the code inside this chunk changed? If it hasn't, it won't rerun it. It will just load the previous result. It saves that locally, right? If I do change any code in here, it will be able to detect I've changed the code within that chunk. The cache is no longer valid. I will rerun. This will save you a lot of time. If you put cache equals true for something which just takes a while. Another really useful thing is to be able to save the reports, not just in your, the figures, not just in your HTML document. Because what people, I will give them an HTML document and then they'll right click the figure and save it out. If we actually specify a figure path, we tell it we want to put it in this directory figures slash, it will then, every time we make a figure, it will copy that figure both into the HTML page and into that figures directory. We can even specify with this dev function that maybe we want multiple types of point plots. And I like PNG because they're small and they're easy to manipulate. But if you're going to use Illustrator or something, you want a PDF because then you can replace parts of it. Right, so that's really giving two people giving two options here is really useful. I get it in the HTML page, but it's also going to save it to this directory. So I get both. I think one of the last things we wanted to kind of look at is the YAML header. Okay, so 90% of the time, you're going to learn how you're going to use our markdown by going File, New File, our markdown. You know, there are options for presentations and stuff here, but we'll just do document. I provide my title. I tell it the output format. Use current date, etc. Here, like I said, PDF, Word. There are more options. And this document is kind of a nice template. So actually, often I start here. I delete the bits I don't need. Where was it? I delete the bits I don't need. This text, for instance. Maybe I don't need those additional code chunks. But that's usually where I start. So I'm usually starting at this point. And this gives just easy for me then to work with. And then I will copy these chunks and write them out and build up my doc. This YAML here actually controls the title, the author, the date, and the output format. And so we've made everything, I think, into an HTML so far. But if I wanted to, I could actually change this to PDF, I think, and I can do that. So I get a PDF, and then that PDF is much easier then for me to print, because HTML prints terribly. If I want, I can do a Word document, which is really cool. I don't actually have Word on my computer. Somewhere here, it's opening. Somewhere, you should have a Word doc somewhere here. Yeah, it's 2.doc. Doing this. It's actually very cool. Passes in all the plots or anything I have there. You can also just make the MD documents as well. So MD documents are very useful if you just want to put them on GitHub. Which knows how to work with MD documents. Great, now I've broken our studio. So I just showed you we can change some of these output formats. We can also set some global options here. So in this case, we've got, let's change this back to HTML document. And then if we wanted to, we can set global options for the whole script, the whole thing. I'm kind of replacing them here. So in this case, it's output. We tell it it's HTML document. And things which I would normally place within here, like figure width, figure height, I can actually place now in the YAML itself. There I can specify I want all my plots to be 7 by 6. So the final thing I think we're going to cover here is styles. And I don't have a particular favorite style. I tend to use pretty much the defaults. That's not true. I quite like Cerulean, actually, now I think about it. But there are a list of, themes and styles for the way you can make your reports look. And you're going to have some opportunity to kind of play around with that a bit. Now, this is the Markdown book. It's called Book Down because Markdown actually allows you to write books as well. Lots of information in here. But I think I was just going to give you an example of like changing the theme and the highlight here. We have a few different options. So if I can do this. So if I now run that. I need to run some actual code maybe to make it a little bit easier. That's fine. Just the way that it fills in the code chunk, it's going to make it black in this case, and it's going to make them green. So you can change kind of the highlight, will control the code chunks. The overall look is controlled by this theme. I think Cerulean is an acceptable theme. Let me see if I can. If that works, it might be E. Oh, there it is. So by getting it wrong, it's told me all the available themes for me. Let's do that one. Yeah, so I really like this kind of style. So all my reports are good. So if you go to the Markdown kind of help page, it will tell you all the different themes available for you, and you will find a theme and a highlight which really suits your style and you think looks neat in your hands. And I'm not sure if anyone here does any HTML development or building tools, but if you do, you can actually customize these things just like they were HTML pages. And to do that, you just provide your own set of styles by specifying CSS and then style.css, wherever your CSS file is, and it will load that in, and it will apply any styling you have in your CSS to your document. Again, if you don't know HTML and you don't know cascading style sheets, this isn't particularly useful to you. But if you do and you like HTML, you can have that level of control over these R Markdown documents. It's a little beyond our scope to go into CSS. So I think I've already shown you a little bit how to do this, but to get started with RStudio, it's very simple. Just go R Markdown, file, new file, R Markdown, name of the file, and then you can just go like that. And it will create this kind of template R Markdown for you with some descriptions on some examples of kind of how to use it. Right, here's echo equals false. So that's the easiest way to get it set up. Once you start getting into R Markdown, you also notice here it said to me from template. And there are tons of kind of pre-compiled templates. And all you need to do is find a package which has that template in. And it's just a matter of Googling your particular favorite template or whatever. So here we have built in with our Markdown, we have package vignette. And I think if I knit that, you can see without having to do anything. It's a very, very particular style to it. So you have a lot of control over our Markdown, depending on how deep you want to get with it. Resources to look at this. Yui is the author. Our Markdown.RStudio is a fantastic place to go. These other are good as well, but probably our Markdown. It's built by RStudio themselves. They will get you some really nice examples about how to get going, including some wonderful videos. So I think we're getting towards the end of the class today. I have an example on reproducibility in R. Okay, so really it's just a matter of open up this documents here. These documents are actually a little trickier to find, so let me find them for you together. So I've downloaded this class. So if I want to open these documents, I'm going to go File, Open File. Go to my downloads. Probably this the I think it's reproducibility, install doc, external data, scripts. We have them here. You should just be able to compile these, knit them. So really what I've tried to do is just take some nice, simple R Markdown documents. I've added every potential thing we've run through. So you can just see them in the actual RMD themselves, and then you can just press the compile button. I think we don't really need to run through these exercises later. I will be around at 5. If you want to be here and you have any questions, let me know. But I recommend you just load these up and start changing, altering, messing with it a bit, and you'll get a good understanding of what happens inside of them. If you can't find them because they're in a slightly different place, just search your computer. If you've downloaded the thing, they are in there. They're just not in the place I wanted them to be. So, okay, so that's the end of our session for today. We covered and we finished all of